Hello! In this video, we will learn about mod query refinements. You can see the patent here. It is quite a large patent. This is similar to what we learned previously about how the entire breakdown process works. The search engine makes changes according to its preference so that the best results can be shown. This patent, Mod Page Query Refinements, was published in 2006. Now, its GUI was tested from 2004 to 2006. It was filed in 2003. It included semantic query clusters for different contexts, followed by the matcher, the clusterer, the scorer, and the presenter. Now we will break all of this down and understand it step by step. Why are mod query refinements done? The goal of the search engine is to display the most promising and relevant search results. However, sometimes users use keywords that limit the search results. Sometimes they are too ambiguous, sometimes too general, and sometimes too specific. So ambiguous means having more than one meaning. General means being unfocused. And too specific means being overly focused. For example, consider the word bear. This falls under homonyms. And homonyms are words that have the same sound and spelling but different meanings. Now, bear means to carry, but it is also an animal, and it also refers to being without clothes or bare. And next is improper context. Let's say there is a word jaguar. Jaguar is an animal. It is also a Macintosh operating system, and it is the name of a car. Then there are very general terms that are excessively broad, such as food. With food, the search engine does not understand whether the person wants recipes, restaurants, food products, or cooking tips. It is too broad and difficult to understand. Next are too specific terms, meaning very narrow terms. These are excessively narrow. For example, a query is Toyota Corolla 2020 red model with leather seats in New York. These results are so specific that very few search results will appear, and most likely the search results that do appear will not even be relevant. The job of query refinements is essentially to modify our query so that high-quality, relevant results are shown. The purpose of query refinements is to provide suggestions that solve such problems and fulfill the user's intent in the best way possible. How query refinements works. If a person searches for Jaguar, according to Google search, it can have many meanings. Jaguar Company, Jaguar Cars, Car Owners Association, OS Jaguar, Jaguar Animal, and other random topics. The search engine will refine these results and organize the entire SERP according to the dominant, minor, and middle level intents. How does Google understand and refine the query? Before showing the SERP, Google will find as many Jaguar-related pages as possible. Then it will select the top 100 most relevant ones. After that, it will group the results. The 100 most relevant results will be organized into clusters, one group for Jaguar cars, one for Mac OS, one for Jaguar the animal, and so on. The articles in these groups are matched with stored information from previous searches so that relevant search terms can be found. What is the function of stored information from past searches? Whenever a person searches, Google saves their previous data. It also monitors what the user clicks on. Let's say 10 million people search for Jaguar. Google stores data on what they click, which words they add afterward, and which results are useful. If a user searches for Jaguar and clicks on the web results, since the dominant intent is for Jaguar cars, Google will show more results related to cars. If someone goes to the images section and looks at more pictures of cars, the dominant search intent in the image section will be cars. If they look at the animal, then the intent for the Jaguar animal will be higher. How does Google match documents with old data? Let's say Google finds 100 top results for Jaguar. It will compare them with past searches from the association database. Google will see which is the most relevant, cars, the animal, or Mac OS. Then Google will check which cluster users are clicking on the most. Are they clicking on cars, the animal, or the operating system? Now Google will cluster the common words within those groups. For example, the car cluster will include car, automobile, and vehicle. The animal cluster will include wildcat or species. Now, let's look at a real-life example. If you have Netflix or primarily watch action movies, the linking will suggest action movies to you based on your past choices. YouTube does this as well. Similarly, Google learns from your past searches and shows better search terms, meaning results based on your history, and also shows search results based on its overall data. Next is finding important words. Google looks for important words for every group, which we call term words. For example, for Jaguar cars, the important words will be Jaguar, automobile, car, and SUV. For Mac OS, there will be words like Jaguar X, Mac OS. Next is suggesting better queries. Google uses this data to suggest search results and search queries in an outstanding way. If someone searches for Jaguar, Google might suggest Jaguar car, Mac OS Jaguar, Jaguar racing, or Jaguar cat. Next is ranking these results. This involves seeing which are the most relevant and how many documents match the suggestion. For example, a popular topic is Jaguar car, and it may appear higher in suggestions than Jaguar cat. After that, irrelevant search results are excluded. For this, the minus sign is used in the back end. Jaguar minus car minus Mac OS minus racing. So next is learning from past searches. Google learns from your past searches and personalizes your search results accordingly. Next is the cluster centroid. The centroid is basically a center or average of a group of documents that are all related to the same topic. It's the ideal or most typical point that represents all the documents in that group. For example, if you have a group of people and you want to find their average height, you write down everyone's height and find a middle point. That middle point is where everyone's heights are clustered. Similarly, in Google's case, all documents have a cluster that has a centroid. This means it is the most common idea to which all documents are attached. Let's say you have a main topic and all your articles are about construction. Your main article defines the main subject of construction as a whole. All other articles will be connected to it, and that page will be the centroid, the central idea that everyone links to, which represents all of them. This serves as the cluster centroid in the Google search process. So whenever Google clusters or groups documents, it uses important words known as term vectors to define the center of each cluster. Then it calculates the centroid to find the most relevant or central words of that cluster. Let's say we have Jaguar cars and this cluster has a centroid. Google has many articles about Jaguar cars. They will have keywords like Jaguar, car, automobile, engine, luxury, and SUV. The cluster centroid will focus only on the most important or central words within the group: Jaguar, car, automobile, and engine. It excludes luxury and SUV because these are found in others. The words of this cluster centroid might overlap with others, but they are the most relevant to the idea of Jaguar cars. They define it. That is why this is the cluster centroid. And next are associations. This is any term or phrase that has been saved in the system, which we call a stored query. A stored query is any term or phrase stored in the system, such as best pizza recipes. A stored document can be an article, a web page, or a piece of content, but it must be relevant to the stored query. If there is an article titled 10 Amazing Pizza Recipes, the association will basically be a link between that query and the document. This link indicates that the document is related to the query. The system recognizes that the article 10 Amazing Pizza Recipes is related to best pizza recipes. Here you can also see the pattern structure: associator, selector, regionator, inverter. These pre-component systems do the following. First, they build a database, they store queries, store documents, and store associations along with their weights. Next, they create associations, meaning links. Relevant stored queries are linked with stored documents or articles, and a weight, important score, is reassigned to each pair. After that, cache data and logs are used. Query logs, cached queries, and cached documents are referenced to improve accuracy. This system has 4 modules: associator, selector, regionator, and inverter. The associator connects queries with documents and assigns weights. The selector picks documents based on search results. The regionator refines searches using past queries. The inverter swaps stored query pairings for efficiency. Now let's first explain the associator. Assigning weights. The associator assigns a weight to every pairing between a query and a stored document. Let's say your stored query is best pizza recipes and the stored document is 10 pizza recipes. The associator assigns a weight of 10. This estimates the relevance, how relevant the document is to the query. The higher the weight, the stronger the relevance. If the article contains recipes and reviews, it will receive a higher weight because that aligns with the user's intent compared to another website that only has a simple list of ingredients. Next is the sum of multiple associations. If a query document pair has multiple existing associations, their weights are summed up. Let's say the query best pizza recipes is linked to a document via user clicks and manual tagging with weights 10 and 5. The total becomes 15. After that, consider query frequency. This means how often people open specific results when they arrive. The weight is then multiplied by this frequency. Let's say the keyword best pizza recipes is searched 20 times. If its initial weight is 15, it will be multiplied by 20 based on its popularity and relevance. Next comes the selector. This selects stored documents based on the search. When a search is performed, the selector selects one or more documents for the associated stored query. Let's say you search for easy vegan dessert. The selector will choose some documents, such as blog posts, recipes, or articles that match the query. It uses two methods: search document chosen post search. These are the documents you click on after the search, which determines which documents to associate. If you choose an article on vegan brownies, that article is selected. The search system determines that the document you selected is related to that query. For example, you search for easy vegan desserts and select an article on vegan brownies. That article will be selected as relevant. Next is the set of search results. It also considers the entire set of search results. Let's say you have a list of 5 different dessert recipes. The selector will choose the one that has the highest relevance. Next is the regionator. This uses the query log. The regionator analyzes the query log to find stored documents that are associated with searchers. If many people search about gluten-free bread, the regionator will retrieve documents related to that query. Next is region rate search results. It can recreate search results using data from previously tracked queries. Now, let's say a user searches summer splash. Even though it is not a new query, the regionator can pull up past relevant results that were stored in the log to ensure the best matches. Next is the inverter, which works with cache data. It selects based on cache data. The inverter examines cached articles and cached queries to create associations. If you have cached results in your browser for DIY home decor, the inverter can link these cached documents with the query. Next is inverse cache pairing. This flips the cache document / cache query pairings into query / document pairings. If the cached pairing originally says document A is linked to document X, the inverter reverses this. For query X, here is document A. After inversion, the inverter selects the cached data to associate it with the corresponding cached data. If DIY home decor was cached along with multiple documents, the inverter will use that data to display all those documents when you search for similar topics. For example, if you searched for DIY home decor and it was cached with other documents, when the inverter uses the data, it will show you all those documents that were cached at that time, even if you search for something similar. Pre-processing. When you search for a query, the system prefers using the pre-computation engine. This engine has 4 parts: the associator and the selector. Once all the old data is stacked up, query refinement occurs. When a user searches a query, the query refinement system improves it. It has 4 parts. Matcher. This matches stored documents with the new search query and assigns a relevance score. Let's say you search for healthy meal ideas. The system checks old searches, looks at related queries like quick healthy recipes, and assigns a score based on how relevant they are. And next comes the clusterer. This groups similar search queries into clusters. It groups them with common word themes. These groups are then ranked based on relevance. If you search for running shoes, the system will form clusters like for beginners, for performance, or for pronation. The highest ranking cluster will be considered for suggestion. Next comes the scorer. This analyzes every cluster and calculates the centroid. Then search queries are scored based on how many documents are linked to them and how close they are to the centroid, the most relevant topic. The scorer analyzes every cluster and calculates the centroid. Search queries are scored based on how many documents appear when a query is searched and how close they are to the centroid. Let's say you search for best affordable trekking boots. The cluster has many pages and all of them match the user's search. Therefore, this query will receive a higher score than a less relevant query. Next is the presenter. The presenter takes the highest scored search query and shows it to you as a suggestion when you are searching, thus refining your original search. The system keeps track of how the refinement was created and then displays only the final suggestions. If you search coffee brewing, the system will suggest best coffee brewing methods, how to make espresso at home, or coffee brewing tips for beginners. After that, this patent was updated in 2017. The score method was updated, then representative queries are chosen based on the centroid. A representative query is chosen for every cluster. then according to cluster size and relevant score, the clusters are aligned. This means the clusters are ordered based on cluster size and relevant score. Finally, the subqueries are used as refinement queries.